Welcome to this third video on problem solving and reasoning. This video is all about problem solving strategies. Let us start the lesson with this problem. There are 18 animals on the farm. Some are chicken and others are sheep. If there are 50 legs, how many chicken and how many sheep are there? So you try to answer this using your own strategy or technique. You may pause this video and try to answer this. One possible solution or strategy to be used to solve this problem is by guess and check, or what we call trial and error, or by using also an organized list. So let's have this solution. For example, we let actually C as the number of chicken and S as the number of sheep. And in this problem, there are actually a given. So given 18 animals, so there are 18 animals. The total should be 18. And for the 50 legs, how many chicken there should be? So we know that a chicken has 2 legs, and how many sheep there should be in this farm? We know that sheep has actually 4 legs, and we need to have a total of 50 legs. Okay, so by using guess and check, let's start with maybe 9 chicken and 9 sheep. That completes 18, isn't it? If we have 9 chicken, that gives you 18 legs here. This is for the legs. And then we have 9 sheep, that gives you 36. I'm sorry, yeah, times 4, that gives you 36. If you add 18 to 36, that gives you 54. So that's actually higher than this 50 here. Okay, so let's try another. So that's higher, so we need to lessen this one. So we have 8 here, and then this should be actually 10. So if we have 10 chicken, that makes 20 legs, and we have 8 sheep, that gives you 4 times 8, that gives you 32. And then you have a total of 52 legs. So that's more than 2, okay, of the needed legs here, 50. So we need to actually again maybe less or subtract here, decrease the number of sheep. So let's start with 7, and then this should be 11 to make 18 animals. So if we have 11 chicken, that makes 22 legs, and 7 here for the sheep times 4, that gives you 28 legs. So the total is actually 50. So that's actually correct. Okay, so we already satisfied the number of legs here, 50. Therefore, we can conclude that in this farm, out of the 18 animals, 11 are chicken and 7 are actually sheep. So that's one solution. Maybe you have a different solution, so but this one is just one. Even you actually use another strategy or other strategies, as long as we arrive at the same answer, we have 11 chicken and 7 sheep, that's still correct. Okay, let us use another strategy using algebra, or particularly the system of linear equations in 2 variables. We can actually solve this problem. If we let x be the number of chicken and y be the number of sheep, okay, and representing the statement, there are 18 animals on the farm, so we need to add these 2 variables here, and we have a total of 18. We know that chicken has 2 legs, and for the sheep you have actually 4 legs, so we can write it as 4y, and the total number of legs should be 50. So that's the another equation form. So we call this a system of linear equations in 2 variables. Okay, so solving this equation using elimination, we need to multiply 2 here and the first equation, Okay, and then we have to subtract the two equations. So 2 times x 2x minus 2x, that gives you 0. 2 times y, it's 2y minus 4y, it gives you negative 2y. 2 times 18, that's 36, minus 50, it gives you negative 14. Solving for y here, dividing both sides by negative 2, you have y is equal to positive 7. So that's one of the solution, or that's actually the value for y equals 7. So using the first formula, x plus y is equal to 18. Okay, substituting the computed value for y, which is 7, we have x plus 7 equals 18. And now we can actually solve for the value of x, that is by adding negative 7 to both sides, or by transposing 7 to the other side. That gives you 18 minus 7, which is 11. And that will be the number of chicken. So we have 11 chicken and 7 sheep. It satisfies the two equations, so you can actually substitute it here. You check whether the two values, or the values of x and y, are actually correct. We have 11 plus 7, that gives you 18. 2 times 11 is 22, plus 4 times 7 is 28. It gives you 50. So the two equations are actually satisfied. Therefore, we have a correct answer. X equals 11 and y equals 7. And that's another solution to this problem using another strategy, system of linear equation in two variables. Maybe you have actually think of another strategy or technique to solve this, and you may actually present it during our synchronous session. Let us now discuss the four-step problem-solving strategy of George Polya. One of the foremost recent mathematicians to make a study of problem solving was George Polya. He was born in Hungary and moved to the United States in 1940. The basic problem solving strategy that Polya advocated consisted of the following four steps. The first one is understand the problem. Second, devise a plan. Third, carry out the plan. And fourth, you need to review your solution. In Polya's four-step problem-solving strategy, the first step is understand the problem. So what do you mean by this? You must have a clear understanding of the problem. To help you focus on understanding the problem, you may consider the following questions. Can you restate the problem in your own words? Can you determine what is known about these types of problems? Is there missing information that, if known, would allow you to solve the problem? Is there extraneous information that is not needed to solve the problem? What is the goal? The second step is to devise a plan. You have to think of a strategy or technique how to actually solve the problem. These techniques may be one of the following. You can actually make a list of the known information. Make a list of information that is needed. You can actually draw a diagram or a figure. Make an organized list. Make a table or a chart. You can actually work backwards and try to solve a similar but simpler problem. You can actually look for a pattern. You can actually write a formula or actually an equation. You can actually perform an experiment or act it out, and you may actually use guess and check or trial and error. The third step is carry out the plan. Once you have devised a plan, you have to carry it out. So you can work carefully, keep an accurate and neat record of all your attempts, realize that some of your initial plans will not work. And this fourth step is so important. You need to look back, or you have to review your solution. So once you have found a solution, check your solution. Ensure that the solution is consistent with the facts of the problem. Interpret the solution in the context of the problem, and ask yourself whether there are generalizations of the solution that could apply to other problems. Let us illustrate some of these problem-solving strategies. Let's start with look for a pattern. For example, the given problem is find the sum of the first 100 even positive numbers. So starting with the first even positive number, we have 2. Okay, the sum is still 2. Okay, for the first two even positive integers we have, or numbers, we have 2 and 4. The sum is 6, and it can be written as 2 times 2 plus 1, or in multiplication we have 2 times 3. And for the first three even positive numbers, which are 2, 4, and 6, their sum is actually 12, and it can be written as 3 times 3 plus 1, or that is 3 times 4. And then we have the first four even positive integer numbers. We have 2, 4, 6, 8. Their sum is 20, and it can be written as 4 times 4 plus 1, or simply 4 times 5. Okay, so looking or comparing actually, or recognizing the pattern from those multiplication form here of the sum, okay, the green numbers here with that of the number of even positive numbers being added, the pink numbers here. Okay, so how do you actually relate them? Okay, so what's the pattern? So looking for that pattern, we can actually see that when we get, okay, the sum of a given number of even positive numbers, we have to multiply, okay, that number of even positive numbers with the next, okay, integer. Okay, and that is, for example, if we have in the problem we have 100, we need to multiply it to the next number to that 100 is 101. So we have 100 times 100 plus 1, or that's 100 times 101, and you have, okay, the product 10,101. So that's the answer to this problem. That's actually the sum of the first 100 even positive numbers. It's 10,100. So that's how to actually use the technique look for a pattern, or looking for a pattern, okay, in solving a certain problem. How about solving a certain problem using an organized list? For example, the given problem is Mr. Thomas is making 3-layered candles. He is using red, green, and blue wax. How many ways can he arrange the 3 colors in the candles? So you can make an organized list to help you solve the problem. Let's start with red, green, and blue. So starting with red, we have red, green, and blue. And the other one will be red, blue, green. So there are 2 ways to arrange colors when red is first. And we need to start with the other color, which is green. So we have green, blue, red, and the other one will be green, red, blue. And there are actually additional 2, okay, ways, okay, of arranging the colors, starting with green. And the last one, when you start with blue, you have blue, red, green, and blue, green, red. Okay, so is there any other arrangement? I think we already use all the possible arrangement. So in total, there are actually 6 possible ways and how to arrange the colors in the candles. So that's how to use an organized list to solve a certain problem. How about this? Try this problem using organized list. 4-digit numbers. Paulo is using the digits 5, 9, 7, and 3 to make as many 4-digit numbers as he can. How many different ways can he arrange the digits? This is without repetition, okay? So you may pause this video and try to answer this problem using the technique making an organized list. So how many 4-digit numbers can be formed, okay, using the numbers 5, 9, 7, 3. So the answer is, we have there, okay, the possible arrangement of the 4 digits. All in all, there are actually 24. So Paulo can arrange the digits in 24 different ways. Do you have the same answer? I hope so. Let us use another technique in solving a word problem. So let us illustrate the strategy making a table. So the given problem is 5 out of 12 students in this school are boys. If there are 96 students, how many are girls? So we need to make a table. It has 3 columns here. We have first column will be for the number of girls, the second column will be the number of boys, and the third column will be the total number of students. So the given is there are 12 students. Out of 12, there are 5 boys. So it means that there are 7 girls. Using this ratio, we can actually increase the number of students until we get a total of 96. So using the ratio 7:5, if we have actually 14 girls, there will be actually 10 boys, and we have a total of 24. Increasing the number of girls to 21, boys will be 15, and that gives you a total of 36. Continuing the process, we have the next 28, 20, and we have a total of 48, plus 7, we have 35, plus 5, we have 25, a total of 60. Then you add 7 again to 35 to get the next number. We have 42 plus 5 to 25, it gives you 30, and a total of 72. Okay, so we have to continue still because we need to have 96. So we have 49, then plus 5 to 30, you have 35 with a total of 84. And then you add 7 to 49, that gives you 56. Add 5 to 35, you get 40, and you have a total of 96. So there you have it. There is the 96 students, the total of students. So out of that, there are actually 56 girls. So that's the answer to our problem, or to the question being asked. There are 56 girls from the 96 students. So 56 of the 96 students are girls. So try to answer this problem by using the technique make a table. Susan and Marilyn both go to the gym each week. Susan goes every 3 days, but Marilyn goes every 4th day. If they both attend on Monday, when will they next be at the class together? So you use the technique making a table. So you may pause this video and try to do it. Okay, so let us now check your answers or your solutions. So we have the table for Susan and a table for Marilyn. So they start at Monday, or on Monday. We actually let that as the day 0. Okay, and then you have for Susan, it goes to the gym every 3 days, while Marilyn goes to the gym every after 4 days. So looking at this table, it means that they will be together and after 12 days. So that will be next Saturday. So on the 12th day, they will be at the class or at the gym together. So that's the solution to this problem using making a table. The strategy working backwards is usually used to solve a problem like this. Jack is 35 years younger than Karen. Frank is half of Jack's age. Jennifer is 17 years older than Frank. And if Jennifer is 35 years old, how old is Karen? So working backwards means we have to start with the last statement. That is, Jennifer is 35 years old. And the next statement is Jennifer is 17 years older than Frank. So if Jennifer is 35 years old and he is 17 years older than Frank, so how old is Frank? So to solve that, or to find the age of Frank, you do the opposite operation of older. The word older, the opposite is subtraction. So you have to subtract 17 from 35, you have 18. So Frank is 18 years old. Okay, so we proceed to the next statement. Frank is half of Jack's age. So the opposite of half is twice, or times 2. So to get or to find the age of Jack, we need to multiply 2 to the age of Frank, which is 18. So 18 times 2, you get 36. So Jack is 36 years old. And we have now the final statement. Okay, the first sentence in this problem, Jack is 35 years younger than Karen. So if Jack is 36 years old and he is younger than Karen, you do the opposite, the word younger. So you need to do addition. So you add 35 to Jack's age, which is 36, you get 71. Therefore, Karen is 71 years old. So that's how to actually uh, do working backwards in solving a certain problem. So Karen is already a senior citizen, isn't it? And they are the ones being prioritized for the COVID vaccination. No, diba? Sagot yan ni Miss Grant International, first runner-up, Samantha Bernardo of the Philippines. Try this problem. David is 5 years younger than Joshua. Simon is 9 years older than David. So if Simon is 12 years old, how old is Joshua? Joshua. Okay, so you please pause this video and try to solve this problem using working backwards. So let's check your answers. So the solution is, we have the statement Simon is 12 years old, so that's given. And then we need to have the next statement, Simon is 9 years older than David. So older, you get the opposite of that. That will be for subtraction. So you have to subtract 9 from 12, you get 3. So David is 3 years old. And you have the last statement, David is 5 years younger than Joshua. So younger here is actually subtraction, but you need to do the opposite. So you have to add. Okay, so you add 5 to 3, you get 8. So Joshua is actually 8 years old. So Joshua is 8 years old. Did you get the same answer? Yes. Let's try to solve this problem, okay, using draw a diagram. A frog fell down in an abandoned well which is 21 meters deep. He found it difficult to jump up the mud-coated walls. He started his long jump up the well at 6 o'clock a.m. It took him 15 minutes to jump 3 meters because the walls were so slippery. At the end of the every 15-minute period, he rested for 5 minutes while he sadly slipped down 1 meter. He continued on at the same rate. At what time did he finally reach the top of the well? This problem can be approached in a number of ways. You can use 25 squares of 1 centimeter grid paper, or you can draw a timeline with 1 centimeter marks. 1 centimeter would represent 1 meter the frog jumps or slips. Drawing the line will help you to visualize the problem. So using this figure here or diagram, we can say that it would take the frog 195 minutes to cover the distance. He would reach the top of the well at 9:15 a.m. So that's the answer, 9:15, because he started at 6 o'clock a.m. and he needs 195 minutes, and that will be at 9:15 a.m. I really like this next strategy, acting it out or using concrete materials. Say 2 adults and 2 children have been stranded on an island in a river. They must cross the wide river to safety, but they only have 1 canoe. The canoe can either take 1 adult or 2 children at a time. How can they safely reach the other side? So you may use concrete materials or blocks to represent, okay, the 2 children and the 2 adults. So let's say we have this illustration. We have the 2 adults represented or denoted as A sub 1, A sub 2, and the 2 children as C sub 1, C sub 2. Okay, so they are on the island, and then they will cross the river to go to the safe river bank. Okay, so there is actually a condition that the canoe can only take one adult or two children at a time. So starting with the first one, the two children will actually ride the canoe and cross the river. Okay, and then the first child, the C sub 1, will actually go back to the island. Okay, and the next one will be the adult. Okay, will actually go, okay, to the river bank, and the adult will be left at the river bank, and the second child will actually go back to the island. Okay, and the adult will actually take, or I'm sorry, it's the two children who will go back to the river bank. Okay, and the second child will go back again to the island with the second adult. Okay, and the second adult will actually uh, go back or take the canoe and be at the river bank, and the first child will actually, or child 1 will actually go back for the child 2, and the two children can now take or yeah, ride the canoe to be at the safe river bank. Okay, and I think that's how to actually solve the problem. Okay, this illustration can be the way you actually move your concrete materials, or what we call blocks. So you may actually use blocks to represent the movements of the family members, and it made you easier to work through the steps of the problem and arrive at an accurate answer. So maybe this is the shortest way of doing it, or maybe you have a longer method of transferring or moving one member of the family to the other until all of them will be at the river bank and they are safe. Okay, so that's how to actually solve your problem using acting it out or using blocks or concrete materials. Okay, so I think this is one of the famous problems wherein acting it out or using concrete materials can be the most applicable strategy to be used. So the wolf, the goats, and the cabbage. So you try to answer this, okay? Okay, you show your answers later in our synchronous session. So we have, may I read the story? The man has to take a wolf, a goat, and some cabbage across the river. His rowboat has enough room for the man, plus either the wolf or the goat or the cabbage. If he takes the cabbage with him, the wolf will eat the goat. If he takes the wolf, the goat will eat the cabbage. Only when the man is present are the goat and the cabbage safe from their enemies. All the same, the man carries wolf, goats, and cabbage across the river. How? How? So you try to answer this one and be ready to share your solution in class during our synchronous session. And let us now try to use I think the most commonly used strategy for any kind of problem students actually applying or employ, or actually using. We have the guess and check. So which of the following numbers, 4, 5, 6, is a solution to the equation n plus 3 times n minus 2 is equal to 36? So by guess and check, or by using substitution here, we have to substitute 4 to the variable n, and you will get 14. Is it equal to 36? No, so 4 is not the solution. So let's try 5. So if n is equal to 5, is it equal to 36? It's 24 here, so we need to try another number, and the final number is 6 here. And by checking whether 6 is actually a solution to the equation, so the left side is equal to the right side, it's equal to 36. So 6 is the solution to that equation. So 6 is the solution to the equation since 6 plus 3 multiplied by 6 minus 2 is equal to 36. Okay, so that's the solution, and that's how to use guess and check or trial and error. Let us also try this problem wherein it's a simple logic question that most Harvard students get wrong. Okay, so we have a bat and a ball cost $1.10. The bat costs $1 more than the ball. How much does the ball cost? So in a minute or three, okay, can you actually solve this problem? So what's your answer? You give your answer during our synchronous session. Okay, so did you get the correct answer? We'll see in our synchronous session. And that's all for the problem-solving strategies, particularly and the four-step strategy of George Spolia and the different strategies presented, like working backwards, using a diagram or a table, organized list, the guess and check. Okay, and if you have other techniques or strategies to solve those given problems, you may actually present it during our or share it during our synchronous session. Okay, so I hope you learned something today. God bless, stay safe. Okay, see you in our synchronous session. Bye bye.